Hi folks, Randy Rice here with the Value of Testing podcast. Over 40 years in software testing, I've seen projects succeed, projects fail, and projects that somehow survive despite themselves. Today I'm sharing the biggest testing mistakes I've seen, and one of them keeps showing up release after release because teams never stop to ask why. I appreciate you being here. If you find the content that I'm going to go over here valuable, then I would appreciate it if you would subscribe, give me a thumbs up. That really does help. So by the time you've completed this video, this podcast, hopefully you're going to see some things that you can really avoid in your own practice of software testing. I've done assessments in all kind of companies over the last 40 years. And it's almost like one of my colleagues said way back a long time ago that he thought that he could probably write the assessment report before he even went into the organization. Now, I certainly wouldn't do that. That would be just totally unethical. But that's just what he said. So, I've been in this field quite a while. In fact, even before I got into testing, I was a developer for 10 years, and I saw a lot of things there, not really great practice. In fact, I have to admit that it was in a time back in the 70s and 80s that testing wasn't really fully developed as a discipline at that point. And people just kind of did whatever they wanted to, and some people tested, some people didn't. Now, I will say that I have been researching since probably about 1995 the top problems that people face in software testing. And I compiled those along with Bill Perry's knowledge into a book called Surviving the Top 10 Challenges of Software Testing. You can still find that out on Amazon.com, and it was published way back in 1997. But one thing that my research has confirmed as I've continued to perform it is that the major finding that most of the problems people find in testing are actually human in nature. If you go down to the root cause, they're going to be primarily people problems. But one thing I've noticed is that even though the technologies and the life cycles may change, the failures and the defects still happen for the very same reasons as they did even decades ago. So let's get into some of these, okay? So the first mistake that I see is that people many times ignore risk. Now, what I mean by that is that they may say, yeah, we understand that risk exists and we're taking a risk by doing this, but they really fail to incorporate it into their testing processes. They basically tend to treat everything with the same amount of rigor or the same amount of intensity as everything else. And therefore, some of the really critical items that need to be tested most thoroughly get insufficient attention. And that's a real problem. And even worse, you spend a lot of time in that kind of mindset where you spend a lot of time with the easy stuff that really doesn't really matter. You might find a typo, you might find something minor, but it really doesn't move the needle when it comes to really assessing the quality of something. I remember in my very first test manager role, I didn't know anything about testing, okay? I was put into that role because I had read a book on testing and I had written a test plan, but I didn't have really a depth of knowledge about what we do in testing, and I certainly didn't understand risk. And the idea there that I learned was that I was really beating up the developers over little nitpicky defects, things that were so minor, and at the same time we were missing some of the most major things. So we had to do really a reset on that whole project where I told the developers, hey, we've been approaching this all wrong. I'm sorry. here, let's try another approach. I laid out a risk-based approach for this. And by the way, this was like in 1988 that I was doing this. And over the years, I actually published that approach. You've probably seen it in various places. Probably didn't know it was me that created that thing. But nonetheless, it was really one of the most fundamental improvements in my own testing practice was to really get a good risk-based view of testing. A second mistake that I often see is that schedule pressures replace judgment. You'll often hear things like, we have to ship by the end of the week, or we have to ship on this release date. Basically, what happens there is that testing becomes very compressed, and you really don't have time to test as thoroughly as you would like. The reality is that we have really shifted in what testers have been able to do over the years. There was a time where people estimated how much time it would take to do testing, and then that would be given to a project manager, and that would be factored into a project plan, and you would get pretty much the amount of time that you asked for, unless the project manager was thinking you padded your estimate and they cut the estimate time in half or something like that. But today, more often than not, we're told how much time we have for testing. This is once again where the risk-based idea comes in helpful, because it helps you understand how much stuff you can squeeze into the box of time, so to speak. But in doing that, you find that you can't get everything into the box of time, all the tests. You're going to have to maybe skip some tests, or maybe do some tests lighter than others, or things like that. And by the way, in this world of schedule compression, automation really doesn't help you all that much. I mean, it helps you with regression testing, but the new test that you're performing in that sprint or in that cycle, whatever it is that you're testing, you don't have the time to create the automation and add it into your library and suite. You have barely enough time to do the test manually. But let me just kind of end on this one with this observation, that every schedule-driven organization I've assessed, and I mean there have been no exceptions to this, every single one of them has struggled with quality issues, and they just cannot get past the need for speed, so to speak. So just take that to heart, that if you're in a schedule-driven organization, you better be prepared to make the best leverage you can with risk and all of that, but also be prepared that you're probably going to have a pretty high number of post-release defects. The third mistake that I've seen is skipping reviews. These could include things like requirement reviews, design reviews, code reviews, and basically anything that you create on a project or in a sprint or in a cycle or anything like that can and should be reviewed. Now, this takes time. AI can help by doing some of the reviews and things, but AI can't fully make up for all the context that's needed there. So, yeah, it can help some, but there's a great dynamic that happens when you get multiple people together looking at something at the same time. And one of the biggest things that you'll hear people say is, I don't have time for reviews. Well, the reality is that, yes, when you first start doing reviews, it feels like, man, this is a lot of work, this is taking a lot of time, but there's kind of a hump that you go over, because the more reviews you do, the easier they become, the faster they go, and people start to learn, I better take more care because people are going to be looking at it. I was doing an assessment at a company back a few years ago, and they just were having a terrible quality problem. So many defects were being found by their customers in production. And I asked the QA manager in one of the interviews, have you guys ever done any reviews? And he said, oh, yes, we had a really great review program at one time. And he even showed me the metrics from it and all of that. And I said, wow, this is really great. I said, what happened here? Why did you stop? And he said, well, our management felt like we were finding so many defects, and then they tapered off, and that we were now finding fewer and fewer defects, that we had found all the defects we were ever going to find with reviews. So they quit giving us time to do reviews. Well, the inevitable happened. The review stopped, but then the number of defects started climbing simply because they quit looking for them. Now, you've also heard me talk about, probably on this podcast, or if you've been in any of my training courses, the coffee pot analogy. And in that analogy, imagine that you're making a pot of coffee, and you've got the filter, you got the coffee, you pour the water in, or if you're doing a pour over, you pour the water over. And so the thing you want to avoid is having coffee grounds in the cup of coffee that you're making, or the pot of coffee, whatever that might be. And in the analogy, think about the coffee grounds as being defects in the thing that you're creating. Now, if you look at the coffee and you see grounds, well, one approach you could use would be to try to pull them out one at a time with some tweezers or something, or maybe a spoon or something like that. Heaven forbid your fingers. But the better approach would be simply to pour that coffee through another filter, because for some reason the initial filter failed. Well, in software testing, what we're doing basically is applying filters to our process, and we're doing things like unit testing, integration testing, system testing, reviews, walkthroughs, all the various angles that we can look at something, and each of those would be considered a filter. And most organizations, by the way, will have 3 or 4 filters. Probably best of class would be 7 filters. I've seen some organizations with 1 filter. Well, honestly, I guess I've seen them with 0 filters sometimes. But the leanest, really, I've seen that people could get by with would be 1 filter. But that's really, really thin. Mistake number 4 is failure to perform root cause analysis. And this is just so big. I really struggled with this one. I thought about making it mistake number 1, but it wound up on the number 4 spot. The symptom here is that you're dealing with the same type of defects release after release. It's like Groundhog Day, the movie, where it's like every day it's the same thing. We're seeing the same things happening over and over. Testers keep finding the same types and categories of bugs. Developers keep making the same kind of mistakes. The managers, they see defect counts on their dashboards that never seem to improve. And the teams, ironically, they celebrate finding defects instead of preventing them. And the organization is really many times treating defects as some kind of isolated event rather than the symptoms of what's really going on, which is a process problem. Some examples might be maybe requirement defects that are caused by unclear user stories, or maybe coding defects that could be caused by a lack of code reviews, or even a lack of understanding of the thing that's needed as maybe expressed in a user story or a requirement. It could be maybe integration defects caused by late integration, or the misunderstanding of what should be going on with an API, or maybe production failures that could be caused by inadequate risk analysis. So the cost here is that it's like going down a toll road. You are paying repeatedly for the same trip, for the same defect in this case. Basically what happens is a cycle. And this cycle is you create a defect, or the developer creates it, whatever, and the tester finds it, throws it back to the developer who fixes it. Then they throw it back to the tester who retests it. And then you go on to the next release where it's totally repeated. That cycle just gets recreated. The defect gets recreated in the next release. And the cycle just continues on and on and on. So if you're finding the same types of defects every release, your testing process isn't really improving quality. What it is it's compensating for a quality problem. Once again, think about the filters. Now, the cheapest defect to fix is the one that is never created, okay? And don't forget that each defect found has value, so don't waste it. You know, this is one of the biggest gaps that I see in how people approach testing. They just fail to close this gap, so to speak, where the knowledge is reincorporated back into improving a process. Well, mistake number 5 is measuring activity instead of value. I recently, in one of the other podcasts, did a whole episode on this where, you know, it's all about measuring the right things. It's as opposed to measuring the things that have very little value. One way to say this is measuring activity instead of value. And so, for example, you may measure how many tests have been performed, but that really tells you very little about the picture of testing. I mean, even as a percentage, what does that tell us? Because coverage can also be very deceptive. You might say that you've got 100% coverage of all the requirements or all the test cases or whatever, but 100% coverage can be achieved with just one test per something. So it's really testing in depth that you're looking to understand. I would suggest, instead of trying to measure things like that, even though, yes, they can be somewhat helpful if the context is given right, instead measure how much rework is costing you. How much are the defects actually costing pre and post release? Now, a little benchmark you might want to remember here is that at this point, the research and the numbers that are being reported in the USA for post-release defects are around $16,000 per defect. And you can do a lot of testing for that. You can do a lot of tooling for that or a lot of training for that. So it's not until you understand how much money is just going down the drain in rework that you really start to understand where you need to start applying your efforts in improving things. By the way, in the manufacturing environment, they call rework waste. Okay, that's kind of something to think about. So the next mistake, number 6 here, is blind trust in automation. The thing about automation is it's a super helpful thing, okay? Especially applied in things like regression testing and those kind of tests. But it's really not so great at discovering defects. I mean, I understand that there are people who they do create automation that can branch out and look at things. But in automation, what we often find here is the goal is for all the tests to pass. My friend Greg Pascal calls this go for green. But really what's happening here is we need to be thinking about what happens even when the automated tests pass. I had this one situation. It wasn't all that long ago. I was doing a lot of test automation work with a major drive-in chain here in the U.S. And as part of the mobile app, there was a feature on that app to search for stores, search for the nearest drive-in. And the automated test consistently passed. Okay, I had the automation where it was typing in a full string like a zip code or a full city, and it was returning a list of the drive-ins that you might find. It wasn't until I started using the app manually that I discovered it did an autocomplete thing, okay? And that's because they were using a plugin think Google Maps for right now. That wasn't the particular one, but just imagine with me for a minute. And so, for example, if I was in Macon, Georgia, and I typed in MAC, it would start showing all the McDonald's nearby. Well, in this case, they were a competitor. I also tried Chicago, CHI, and guess what came up? Chick-fil-A. So all the Chick-fil-A's nearby came up. I've logged this actually as a defect. Well, it was something that couldn't be fixed because they were using this plugin, and therefore they just decided to live with that. But the point of the story is that automation didn't pick up on that at all. It was only when I did the manual test that I saw that. It's only when humans start looking at things more deeply that they discover some of these unknown problems. Mistake number 7 is treating testing as some kind of separate phase. And as reality here, testing should influence decisions throughout development. As I often say, don't shift, spread. You want to spread out your activities. Anytime you start talking about shifting, like shift left, which, it's not a bad thing, shift left. In fact, I was glad to see the recognition that's been around for like 30 years that we do need to do things earlier. But it kind of gives the idea that just shifting left is all you need to do. We actually need to apply equal effort in finding defects all throughout the life cycle, because the products that we're testing and the work products that lead to the products that we're testing, they're all going to go through changes. They're all going to go through this kind of maturity path, okay? Now, mistake number 8 is confusing monitoring with testing. I also did a recent episode on this about AI, agentic AI, about how I really don't think it can fully be tested as we think about testing in a safe environment. When you think about the classic view of testing, it's performed in a safe, controllable environment. You can repeat things, you can reset things, you can actually control how you're going to see things performed in that environment. But the thing about it is, after the software or whatever it is you're dealing with is released, that's when monitoring begins. And also, what begins is the high cost of production failures and defects. Once again, think about $16,000 per defect on average, and you can kind of see the scope of that. Now, the cost alone is just one thing, but you can also see loss of reputation, loss of trust, other kinds of cost, not just primarily dollars and cents. Now, mistake number 9 is ignoring or delaying non-functional testing. Basically, what this does is it saves up all the risk until the end of a release. At that point, it may be actually impossible to mitigate that risk. Now, this could be things like usability, it could be things like performance or security. These things get baked into the software. They're designed in. They cannot be tested in, they cannot be patched in. They have to be tested throughout the life cycle of something if you're ever going to be effective in finding them. Something else about non-functional testing is that they each require their own set of skills, many times their own tools, their own environments. And so there's something that people sometimes like to think, oh yeah, we're going to get around to doing performance testing at some point. But you want to try to do that kind of testing as early and as often as you can. I've told the story before on the podcast, but I'll tell it again real quickly here. The very first consulting engagement I had going out on my own was a water utility project in my own home city here of Oklahoma City. And when I arrived, they were in the middle of doing system testing. Now, I had just come from a project in my previous employer where It was the same hardware, the same database, the same code generation tool, and everything. And we had extreme performance problems on that project. In fact, we had to roll back the new system, I think, 3 times and put the old system back in before we ever got a grip on the performance problem. So I just asked the innocent question, has anyone done a performance test on the system yet? And the project manager just kind of looked around and said, no, I don't think we have. So they decided, okay, we need to do that. Well, at the time, there weren't all the great performance tools we have today. So they brought in like 40 people. They were auditors from an accounting firm. Super expensive test, as you can imagine. And they discovered that only 4 people could get logged into the system at the same time. They said, well, not to worry. Let's try the nightly batch run. And so they ran what typically would be a nightly run of all the water bills. And when you're dealing with a large population, you have to kind of split it up. So every night of the month, they would run a certain number of water bills. And it typically ran in the old system about 2 hours. The most it could run would be 4 hours before it started to impact anything else. Well, the first performance test ran 96 hours. In fact, we were taking bets on how long it was actually going to run. People were thinking, well, should we stop it? Should we let it run or what? Well, as it turned out, that system never saw the light of day. The performance issues could not be resolved with the level of hardware they had. The only solution was to go up to a mainframe, and the city wasn't going to pay for that. My client wasn't going to pay for that. And so it just went into litigation. And the city got all their money back, and it was a long story after that even. But the next vendor, they went bankrupt in the middle of system testing too. Eventually, 5 years later, we started getting new water bills. But my point there is that you just do not want to save up those kind of things until the end. Finally, mistake number 10 is failing to retain or capture knowledge and experience. All the lessons you learn in testing are valuable, and all the things that you learn about the thing that you're testing really needs to be captured. This is where test documentation really comes into play. I know a lot of people, maybe you watching right now, you don't believe in creating test cases. You don't like them. You think they're a waste of time. I personally like test cases because they give me repeatability. But whether you like test cases or not, the thing that you want to capture is what you're learning, okay? I don't think any of us would say, I don't want to learn, okay? So capture what you learn in a knowledge base or some other kind of tool or something like that. This leads to avoiding repeating your mistakes over and over again. And, this is also a good opportunity to start making some checklists. Now, I know there's a lot of controversy around checking versus testing and that kind of thing. I personally think it's semantics, but checklists are good no matter what you're doing. Thankfully they do them on airliners, and doctors use them when they're doing a procedure, and the medical profession, they become a big thing, and many professions that are really safety critical, where things have to be done right, they're using checklists. These checklists are based upon things that have happened in the past and things that they want to avoid here in the future. Well, I hope these 10 mistakes can help you avoid some of the things that you may have in your projects. Just remember, even though maybe the tools have changed, maybe some of the programming languages have changed, AI has changed a lot of things, but the fundamental causes of software failure remain surprisingly consistent. Hey, I would love to hear if you find any other mistakes that you think you would like to add to this list. Please put them in the comments below. I would love to hear about those. Once again, Share this if you think it's been helpful to you. Subscribe and thumbs up. It helps me on the channel here. And I thank you for watching this, and I look forward to seeing you in the next episode.